Hello, how y'all doing, Facebook world? This is your boy Veal, President, CEO of It's Not Complicated Tutoring. Real quick before I begin any kind of lesson, YouTube told me my original video was a little bit too long. It was about 20 minutes. I think it needed to be 15 minutes. So I'm making another one as my test video intro on derivatives. But just real quick point before I do that, I want to say thanks to the Lord Jesus, because he's definitely made 2010 a good year for me as far as my business is concerned. Clients, New York City, clients in Atlanta, Texas, just all over the place. I'm trying to go nationwide, so the more things that I do, the more topics that I cover, I think it's going to be a good look in the long run. To people that want to own their own business and are tired of working their own jobs, you might make a lot of money doing what you do. That's all good, but if you love what you do, money will come. My mother always said that, and I love what I do. I have a passion for it, so it gives me the fire, it gives me the energy, it gives me the I guess you say the drive to do what I do better and try and make everything that I do with tutoring and education better. So make sure whatever you do in life is just something that you love. Okay, I'm gonna give big ups to my moms who give me this HD camera to do my tutoring sessions or online Skype sessions with. It's a good look. I love it. Also a shout out to my VP of Operations, Chanel Watson. Yo, to the Deltas out there. She's a DST. Outstanding and phenomenal help on my operations side. Shout out to her business, Chanel's Heavenly Treasures. She's outstanding at baking, like cooking, everything. She's a chef. Look out on my Facebook for her cupcakes, her website, Chanel'sHeavenlyTreasures.com. Look out for her cheesecakes, cakes, Greek cupcakes. Everything is really going down in a major way for 2011 for her business and my business. Look out for us, please, because we're going to be on the come up. Also, I want to give a shout out to everybody else out there that's striving to do good and do the best they can to be an entrepreneur. Alright, so without further ado, let me go do a little bit of a session real quick and try and get this uploaded to see how everything works out. So let's look at some derivatives real quick. The first point I want to kind of touch upon is my previous video. I covered the constant rule and constant multiple rule. Let's look at some other things here. Power rule. For instance, if I have an equation, or not an equation, but if I have a polynomial as such, d over dx of x squared, and I want to know basically how do I take the derivative of this particular polynomial. So what I do is I follow the format nx to the n minus 1. Now what that translates into is having a format as such as this: d over dx of x to the exponent. Okay, then this is my actual problem in case, and then the next part I would do is to get the derivative of this particular format, I bring the exponent to the front, so it'll be exponent, and then x to the exponent minus 1 minus 1. Something similar to this right here. And we're going to do an example of this here very shortly. Let me make sure that you guys can kind of see everything here on just the camera a little bit. Alright. There we go. Sorry about that. Okay, now let's look at this. So an example of this would be something like d over dx, alright, of x squared. So we bring the 2 over to the front and we have 2x to the 2 minus 1. So it's 2x, basically 2 minus 1 is 1. So we end up with just 2x by itself. So 2x would be my answer for my derivative. Okay? Let's look at another example such as this. D over dx of 3z, or 3z cubed, excuse me. So if we use the derivative rule on this particular situation, we're going to take the 3, put it in front. 3z to the 3 minus 1 gives us, 3 minus 1 is 2. So 3z squared is my derivative. Has anybody any questions so far? Alright, so far it's not too bad. It's really basic stuff that we're doing at the moment. Okay? Now, let's look at some more problems here. We have x to the negative 3/5. The derivative of x to the negative 3/5. So you're asking, how do we really figure out this particular derivative? Well, we already have negative 3/5 here. Okay? So we're going to take the negative 3/5 and push it over to the left in front of the x. So we have now negative 3/5 x to the negative 3/5 minus 1. And for those of you that remember fractions, right, we do 1 and 3/5. 5 times 1 is 5 plus 3 is 8. So it's actually, in this case, negative and negative. So it's negative 8/5. That would be my derivative answer here. If we have a fraction of some sort, like 1 over x cubed. Let's take the derivative of 1 over x cubed. So a little bit of a trick here. I don't want to take the derivative straight up because it's going to force me to do the quotient rule. We don't know the quotient rule yet, but we're going to get there. So slow your roll for a minute. What we're going to do is take the x cubed and translate it to x to the negative 3. Whenever the variable is in the denominator, we then push it back up to the numerator and give a negative exponent to it. So to find the derivative on the power rule, we do push negative 3 up to the front. We get negative 3x to the negative 3 minus 1, which is negative 4. And we have our derivative. But wait a minute, you might be asking me, Jay, what do I do next? It looks a little odd. So in this case, what we do is, based on our rule, we should already know, right, from algebra 2, hopefully, or algebra 1, we're going to take the x to the negative 4 and put it as 1 over x to the 4th times negative 3. So we're going to get, in the end result, negative 3 over x to the 4th. That becomes our derivative. Alright? That's how we do this particular problem. Okay? Next up, we're going to go over a fractional exponent. Let's look at that. The derivative, I'll do that one in black. The derivative of x to the 1/2. So now you're like, okay, Jay, how do we do a fractional exponent? I'm going to tell you, just relax. All we got to do here is take the 1/2 to the front again. 1/2 x to the 1/2 minus 1. Now this translates to 1/2 x to the negative 1/2. Now, there's a little bit of a twist to this problem for the simple fact that when I have 1/2 x to the negative 1/2, the negative exponent, what does it do again? It goes down to the denominator with a positive exponent this time, so it equals 1 over 2x to the 1/2. But if you remember correctly, back in algebra 1 again, x to the 1/2 is a square root. 1/2 exponent, or an exponent of 1/2 is a square root. So this goes down to 1 over 2 radical x. And this, my friends, is the derivative. Alright? I'm going to move on to one more. Before I cut this part off and do another video. Alright. What about the derivative of 1 over cube root of x? Now, tricky thing about this is that the 1 over the cube root of x translates to x to the negative 1/3, because it's in the denominator. So x to the negative 1/3. At this point here, I then follow my power rule, if y'all remember correctly. So I get, in this case, I get negative 1/3 x to the negative 1/3 minus 1. 1 and 1/3 is 4/3. We have two negatives, so it's negative 4/3. Now, I gotta find out what my answer is. Is this all we can do? Or do I gotta move it down like I did here? Negative exponent, I move down to the denominator. So my answer is going to be, in this case, drop it down. Like I say, drop it like it's hot sometimes. We're going to do negative 1, alright, over 3x to the 4/3, and we're done. Does anybody have any questions on what I did? If you don't have any questions, then I will move on to the next video and we can go ahead and get it cracking on that. Alright? Till then, peace, love, and shout out to the noobs. Yo.